here is the region S. You can check that the y-intercept is 4 and the x-intercept is 2. And the question is to find the mass of this lamina. Oh, I should really have said lamina. Lamina is a flat object. Okay, so imagine that this is a flat object. It has some small thickness, but we don't care. But its density is given, mu equals to 2x, and we want to find the mass. Okay. So how do we find the mass? M is?
Integral of dm.
dm. But because this is a two-dimensional object, you actually have to figure out which way you want to cut it.
So would it be almost like the washer method, right?
Not the washer method, but the area.
Oh wait, because we don't have to rotate it around.
Yeah, this is not rotated around, so it's nothing like volume of revolution. It's similar to the finding area between two curves. Okay. So how do we find the area? We cut it into small strips, right? And we only know how to do it in two different ways. If you go to multivariable calculus, you're going to learn other ways. But right now, when you have this way for an area, you only know two different ways, which is horizontally or vertically. Okay? So we just have to pick between the two. Which one should we do? How should we cut it? Huh?
Vertically.
How do you know it's vertical?
Because why? Well, you
Because
could
there's
do both,
only-
I guess, couldn't you?
Because dx is only 2, and it's easier to just go over 2 than go over 4.
No. Well, you'll see that one side works and the other doesn't, simply. Okay? But the vertical is right. Okay?
So you're supposed to.
Oh, I'll get there. Okay, I'll tell you why it should be the vertical one, not the horizontal one. Okay, so we cut this into very, very small pieces, and each piece is what we call dm, and we're adding those mass, and then you get the entire thing, right? But what is the mass of this small strip? Well, first, what is the thickness? What's the thickness of this strip? What is it?
dx.
Yes.
dx. It's a small thickness in the x direction, so it's dx. And when it's the vertical length, we learned that we should get it by top minus bottom, right? If it's a horizontal length, we do
Right minus left.
right minus left. Okay, so we do top minus bottom. So this will be top minus bottom. But what's the equation defining the top? This one is y equals to
4 minus 2.
4 minus 2x, right? What's the equation defining the bottom?
Y.
Bottom piece. This is y equals to 0, right? And you're trying to get this length, which means top minus bottom. So this would be 4 minus 2x minus 0, top minus bottom, which is just 4 minus 2x. And then what's the area? The area, the very small area of this would be base times height, right? So height 4 minus 2x
Times dx.
times dx. The problem with this is that this is not yet the mass. This is only the area. Okay? So what do we do?
You take the surface density,
Mm-hmm.
which is what is it, the mass over area.
Right. So surface density is mass over area.
So it's just again.
So mass would be
surface area.
times the area. Right?
Okay.
So our dm would be actually what?
Would be
Mu, which is 2x, right?
yeah,
Times 4 minus 2x
dx.
So that's my dm. Now we can do the calculation. So this integral dm is now the integral of 2x times 4 minus 2x dx. And x goes from 0 to 2, right? Which is the integral of 8x minus 4x squared dx. 8x integrates to 4x squared. This would be 4/3 x cubed And you have to plug in 2 and 0. And then is 16, 48, 32, 16 over 3. Okay, now back to the question. Why did vertical strips work, whereas if you try to do the horizontal strip, it's a bad idea?
Because your
Because it's
surface
in terms of
density is
That's exactly right. The surface density is given as a function of x, right? And because it's a function of x, we only know how to integrate by dx. If we did dy, then I don't know what to do. This is given as dx, 2x, so it's impossible. So here's the second question. Well, Q3. What if everything's same, but this time mu is 2y instead? What would change?
then
You would rewrite.
Now you have to do dy instead. So what you have to do is this has to be solved for x. So x is really y minus 4 over 2 if you solve. No, 4 minus y. Sorry. 4 minus y over 2. And this is x equals to 0. So if you do right minus left, it's 4 minus y over 2 times dy gives you the horizontal strips, very thin ones, times our surface density, and y goes from 0 to 4. And that's what you have to calculate, and I actually did this calculation before coming here, so I know the answer. It will become 32 over 3, okay? It's a simple calculation. You just have to cancel the 2's and multiply out. It's simple. But my point is this. In Calculus 2, in this class, we can only do problems like this when your mu is given as a function of x only or function of y only, and that would dictate whether we use the vertical strip or the horizontal strip, okay?
So if it's just 2, then you can't do it.
If it's just 2, then you can, either one would work, actually.
Oh.
But you know, if it's just 2, then it's a uniform object, so you just find the area and just multiply by 2. That will be the mass. The fun is when it's not a uniform one, and you have to use integration to solve it. Now, that would lead you to another question, which is like, what if it is a function of x and y? So if you have mu equals to 2x plus 2y, what do? Well, in that case, you have to use calculus 3. Okay. So if the question was like, if mu was like 2x times y, 2xy, at our level, we can't handle it. But if you go to multivariable calculus, you can use double integrals to calculate that as well. Okay? And same idea, by the way.